First of all, I have to thank you on behalf of Huawei, really, to invite us here and give me this chance to I want to address on two things. The first, how we, especially my team, and therefore at the European Research Center, we see the quality and user experience to be measured and how we believe we can troubleshoot the network. I will cover the mobile broadband networks. But then I want to bring onto the table something that currently I haven't heard much today, is the future internet. So what are the key technologies the CT part should really consider, because me personally, I believe that the future networks will be mainly IT networks. Said this, I think we start reviewing what we're doing on the user-aware customer service assurance, future network technology, and then I try to explain how the QoE can be addressed in those networks, some conclusions and open point that currently don't have an answer. Okay, customer experience management, I think it's clear to all of us. This is taken from the Telemanagement Forum definition. When we talk about customer experience, we have four distinct aspects that we have to consider influencing the end user experience, which go beyond the service quality. So we have the brand image, we have the customer-facing end-to-end processes, very important. I have, for example, personal experience that to offer me one operator, the DSL, I had to wait 4 months, to cut the service 3 months. So this is not an experience. Yes. Pre-service marketing and service quality management. So my speech relates to the service quality management, in particular addressing a solution for customer service assurance. Quality of end user experience, we all know that it is an end-to-end problem. The QoE is currently considered as a subjective indicator, so very strictly related to the person and the environment around this person. When you come to what influence the end-user experience, is definitely an end-to-end problem, and any part of the network, from the server down through the infrastructure, can really impact the end-user experience. And as an example, I have recently renovated and modernized my house, and I've deployed, I think, the best home network. I have 1 gigabit per room, Cat7, wireless, 300 mega downlink, VDSL. You won't believe it. Using my smartphone, my YouTube still rebuffer every now and then. So it must be an end-to-end problem. So it's not like the Telefonica in Germany to blame, right? So it's somewhere else the problem. We have to address that. But when you come to the troubleshooting, it's definitely a network perspective. So we need to segment the network and localize where the problem is, and then bridge the symptom to the cause. How do we assess the end-user experience? This slide is a good summary. You can spend a lot of time in internet, literatures, believe this, there are only 3 methods to do that. The first method, I call that as the traditional way of doing that, already addressed by the previous speaker. What is it all about? You make a lot of measurements, then you have a sort of subjective indicator, even the people complaining to you. And then you do correlations, yes? It's a lot of work, and which parameter to take, counters, does not scale, because maybe in that city it correlates well with that parameter, another city, another parameters. I don't believe into that. Though I have a team expert in analytics, we sometimes have to do that because the customer wants, but it's not definitely something that really nicely scale. The second method, pretty new, you find several papers on this, which is based on interaction between the end user and the terminal device. So if I'm not satisfied, I have some interaction with the device. So you should be able, by measuring the device, to identify this, model it, and report to the network. What it requires that the key performance is measured more at the end user, and then feedback into the network. So anytime you measure at the end users, there are problems. Somebody mentioned some problem already today. So I think that's really something that might not be a viable solution for the future internet. So what's the right way of doing that? And we are working on this, and we have a solution to this model, is to model the service. We need to model the service. So So each service needs to be characterized. So if my end customers, they are enjoying YouTube, I have to characterize a YouTube session. If they just browse, I have to characterize browse. If the telephone, I have to characterize the circuit-switched or packet-switched voice call. So that's the valuable model. This is where we have researched, we have patents, and currently we are implementing the solution validated with some of our customers. How does that work? What problems do we address? I don't have animations, so let's try to follow. So currently you have the network infrastructure, then you have all these counters, measurements, then you derive a sort of KPI, which is a set of parameters you believe important for make your network transparent. And so down to high-level indicators, say, okay, this indicator is for the retainability. This indicator is for the accessibility. That indicator is for the integrity. Now I remember all the parameters. But yes, but how does accessibility, integrity, and what was the third one? Accessibility, integrity, and so this is parameter related to the end user. No one knows, right? How does integrity relate to the quality of end user experience? We don't know. So you have a lot of work to model, bridge this parameter at the end. You still don't know whether your end customer is satisfied or not. And we believe we have found a solution to this problem. We model the service and we bridge the service to particular key QoE, key quality indicators. How we do that? It's a very interesting and novel approach. We look at the session itself, end-to-end, which means to measure let me call it that, the layer 7, so the protocols that are really close to the end users. That doesn't mean you need to measure into the device. No, you can provide that, you do the deep packet inspection, you scratch into the protocol, you can measure also into the network, and the network approach is what we believe most. So how we model that? Let's take a particular session, like a web browsing session, so an HTTP session. So what we do, we characterize the session in terms of states, and it's a transition from each state. And within each state, we have models that they bridge particular parameter we measure at the application level and the QoE. QoE meant as an indicator from 1 to 5, reflecting the mean opinion score of the end user. Similarly, into the state transitions, we have other indicators that they impact and model the end user experience. Like, for example, if I have to wait too much before the web page is downloaded, I'm going to measure it and I'm going to report that as a key indicator into the final model. So we characterize the sessions in terms of states and transition between one state and another. I have some example here. We have already developed the model for the web browsing, YouTube, circuit switch voice. So here you have some examples where you can see, for example, for the YouTube, we have 3 states. One of the states is characterized by 3 embedded states. And then out of each state, we can derive the quality of user experience. And now the graph below report in time this indicator, which is computed along with the consumption of the session. So when the end users click the button to go to the internet, we start computing that and reporting that in real time. This is a fantastic solution. Why? Because first, it really models the end user experience. So we don't talk accessibility, retainability, integrity. No, we derive an estimate which you can compare to a mean opinion score that you may attain with a sample of people asking their opinion. Along with that, we report 3 important parameters. You see in this graph, we measure real time, we integrate from the past experience so that we have a way of averaging it out with the history, and finally, at the end of the session, we can integrate it to say like that, for example, that user watching YouTube at that particular time of the day, by segmenting the data and the parameters, was or was not satisfied for expressing a number from 1 to 5. What is extremely powerful in here, where is the professor? We can do troubleshooting. Why? Because once we have identified, for example, a degradation in end user experience, we can double click into that and zoom in into the lower level indicators. The model we have given a name is user-centric service modeling, so you will hear about USM. In addition to that, as I say, we do troubleshooting, and we have evolved another concept to troubleshoot the performance or deterioration of the QoE into the network. We call it UTS, user-centric, still taking from the end-user experience, troubleshooting. How does it work? We don't work with KPI. We don't work with the counters, because this is already biased. That is the old approach. How and what we work. We work with session data records, and we work on transaction data records. So for each particular service, we have different session description records, out of which we derive the key quality indicator, out of which we derive the quality of end-user experience. For troubleshooting, we take a look at the stack supporting that particular session, and at each segment and interface to the network, we define the transaction data records strictly related to that particular protocol. And then to troubleshoot it, when we have a deterioration of the end-user experience, we do a correlation between the SDR, TDR, and then, therefore, we can derive the KPI and, therefore, localize the symptom. The next step will be to bridge the symptom and the cause, which we are currently still studying how to do that. Why it's so important? Because we have a solution who can bridge accessibility, maintainability, integrity, KQI, and the end-user experience, and enable several use cases for the operator. And currently, as you see in there, we are testing and finalizing implementation of this user-centric troubleshooting. The solution is technology agnostic. Why? Because we look at the service application level that can across theoretically any kind of transport network, access network, and we believe also valuable for cloud services. Right, now let's take a look at the future network technologies. I spoke about cloud services. This morning I didn't hear about that. I wonder whether Telefonica is going to offer cloud services or not. Ah, fantastic. So we can measure them. So next, the internet. I made a review. At the end, you have a comprehensive list of references of what's going on in the world on this topic. I found very interesting effort, and we are also participating at the European level. Here you have a summary of the key requirements, and across the world there are many, many initiatives, and I paid particular attention to the US, ITU, and the European Union is already financing more than 150 projects, and all these people doing here? There was a fundamental question. And currently, we are in 5 key research topics ongoing. I just go quickly through them. So looking on the left-hand side, we have a lot of studies around the content and data-oriented paradigms to address what? There's a strong belief that the future internet will not be much host-to-host like today's IP networks, like I am recognized based on my IP address, but will be based on the content, information, distributions. Therefore, we need new technology for doing so. Similarly, we have an interesting thing that a lot of intelligence goes mobile, computational power like smartphones. So we talk about mobile computing. Therefore, we need to study the new way to bring mobility and ubiquitous access to the network resources. And then we have the cloud computing. So that means migrating storage and the computation into the cloud. I have some slides later to address more this problem. Then security. Security is a fundamental issue which also will impact the architecture, because what they try to do that is to have that as an architecture design goal rather than an overlay like as today. And finally, a lot of work has been done and already available in the experimental test beds, just to test whether all these new technologies are working and what are the benefits, etc. So in short, what's new here? Yes. So that was the fundamental question for us coming from, say, the CT coming. We should pay particular attention, which I strongly believe have a huge influence and impact into the mobile broadband network. We have 5 key technology coming, brand new, fresh new. The first one is about information-centric networking. There are already some protocol available. NetInf, for example, in a research study done in the Europe. Then you have cloud networking, which is not about just cloud computing, but is about distributing the possibility of computing and make different type of network collaborate. You have the open connectivity, which is about opening the interfaces so that the two networks, physical infrastructure, they can speak each other, and the infrastructure can speak to the user. Then you have virtualization. Virtualization has different flavors, like now comingly, not very recent, from 2007, 2008, the open flow concept. And finally, you have the autonomy networking. Autonomy networking, which is not SON, which is not SON. SON is mostly around optimized setup parameters, optimized performance, self-configuration. Autonomic networking here relates very much to the possibility of self-configuring, self-managing virtual networks. Okay, said this, there are already several existing test beds. And the question is, if those are the future technology coming, they will definitely have an impact to mobile networks and fixed networks. For the quality of end-user experience, what will then change? What we need to do? If we look at the 2 dominating frameworks for the future internet, you have 2 approaches which they strictly relate to each other. You have on the left-hand side, you have the CT framework, our framework. I'm coming from that domain. On the right-hand side, you have the IT framework, put and driven by the IETF, which I believe will dominate. If you look at them, you will end up into 3 main layers. You will have the physical infrastructure. Let's analyze first the left-hand side, on top of which there will be a virtualized substructure, virtual resources, and then you have the virtual network. Look at the IT, they go much deeper. They have better approach, much clearer way of proceeding. So you still have the physical resource layer, which consists of 3 things. Definitely they have the network, connectivity, storage, which means about the hard disk, server, CPU memory. That's the computational part of the network, the physical network. On top of it, we have the resource abstract virtualization layer with an hypervisor where all the resources theoretically can be virtualized. Now that you have all resources virtualized, you need a layer to control them, to manage them, which means you are going to do admission control, scheduling. But there is an important feature which relates to the cloud networking, is the inter-cloud resource control, the possibility of using different virtual resources belonging to different networks. And then you have the services, the revolutionary or evolutionary services, like software as a service, platform as a service, infrastructure as a service. How the 2 things relate to each other? I made a simple exercise. Though the gray part is yet here to be discussed, I hope we have some thinking, because I would like to understand more from you, expert, how this new technology will definitely impact the mobile broadband network. So you look into here, you still have the network infrastructure, and you have the virtual network. At the same time, I try to define the new players, the new role. You will have an end user, no problem. You will have a service provider, yes, no problem. Yeah? It could be an operator, it could be like Google today. And then you have new players. You will talk about a physical infrastructure provider or several infrastructure provider. You will have a virtual network provider, which will deal with several infrastructure providers. Therefore, we have a fast interface to determine the quality of end-user experience parameters. Then the virtual network provider will deal with 1 or more virtual network operator, and the virtual network operator will deal with the service provider and with the end user. Therefore, we would have 4 new different interfaces to measure and address quality and user experience. If you want then to bridge, that's basically the evolution of the, let me call them, city network. If you then want to consider the impact of the IT network evolution, then we need to do some mapping. And One high-level mapping could be like, say, the infrastructure provider. It could be a cloud provider in terms of carrier, networking, and then you will have the cloud provider that you can position at different level. It could be even a cloud carrier provider. 2 minutes. And then you have the cloud consumer, which could be an end user, or it could be like an enterprise. So what are the main challenges? I think there are several challenges. And the first challenge, I think, relates to the network design. And it's about instantiation time of the virtual resources. It's about isolation between virtual resources. It's about the complexity of managing the quality and user experience. If we look at the QoE itself, I think they will apply the same concept as I presented before. If you measure at the application level, you will have several problems when you do troubleshooting. Why? Because it's difficult to identify where the problem is. Is this a problem of isolation of virtual resources? Is a problem in infrastructure? Is a problem in compatibility between physical interface? That's very complicated. I had some thinking about that, and I made one slide, and then I conclude. So how our research, ongoing activity, will apply to future network. I think we have already a solution for that. We just need to introduce one more parameter. Our QoE study, they do hold. We work on SDR, session data record. We can still address the QoE, even for cloud services. No problem. It's just a matter of designing a new model. Then we can apply still our troubleshooting methodology for the physical TDR. We just need to introduce a new concept of the virtual TDR, and the game is done. So some conclusions, and that ends my speech. We have to accept that there will be a huge impact of the future internet technology onto the mobile broadband networks. I hope during today and tomorrow we get around some understanding around this. And we believe that our models currently derived for estimating the quality and user experience troubleshooting apply also to future networks. We also believe that the internet QoS in future networks must be based on the user-centric approach. It's not just enough talking about bit rate, yes, but to account for that particular bit rate, who is it? We need to consider the quality and user experience. There are different interfaces that needs to be standardized, and there are different service level agreement needs to be clarified. And finally, I think that all these things will nicely happen if we manage to standardize, not right now, the KPI, KQI, we need to standardize transaction data records and session data records. If you do it, you make everything transparent. So thank you, and if you're interested more on the presented topics, I think you can spend some time on these references. It's about a couple of thousand pages. Thank you.
So, any questions? Down here, please.
Thank you. Just a question about the web traffic, about modelization and everything. Since recently now the mobile applications are using web as a way to transport data, I'm a little bit skeptical about the way you will modelize web with this kind of simple modelization tool, because the web is very complex. Now it's a transport protocol by itself. So I'm like skeptical about the way you can modelize it from, it's typical to each website is having its own basically inside protocol. So how do you will able to extract a model from this and to get some kind of quality of experience on this? Thanks.
I think the approach is still to characterize the one or the several. I asked this question to the other speaker, and I didn't grasp the point. So we discussed about the measure. That's not the point. Everybody can measure. The point is, how can you say that, okay, now it starts my web page, now terminates. Now I am opening for each file I have on the web page, a different, how am I going to do that? Yes, we have studied this, and we have managed to define some states and some indicators so that we can really explore what happened through the one or many sessions the HTTP is opening while you're dealing with a web page. If you then end up to open a YouTube, we have another model which deals with that particular content. So our idea would be to characterize, macro characterize the web page itself. We have a way to say that the page starts now and terminates now. And then at the same time, we can bridge our models so that for that particular content, we can, if it is just a downloading, we have another one, or if it is a YouTube, we bridge to the other model. That's how we have done it. If you want to know more, we can have some talks offline, since we have also experimental data out of it. And we are open to learn, so I'm also open to know more if you have better solutions, better approaches to do that.
Hello, this is Jaime Yuk from Telefónica. One question, I know I'm very interested about your model, about this states to model service. And you derive quite of experience type of MOS based on a combination of these individual KPIs from each of the states and transitions. My question, and I'm curious to learn how you account for example, what is the impact of the content in terms of the quality of experience. For example, you are modeling a specific service, I don't know, web browsing, for example, with a specific set of states and transitions, but impacts of for example, the kind of content that these states are accessing to or are related to, how this is included in the model to account for it in the quality of experience indicator estimation.
Probably relates to the answer I gave before, like if a web page, if you go to YouTube, for example, you have an experience to reach YouTube web page, and then you click and start downloading this clip. So the model is simple. We first model the access to the YouTube and the web page. When the video clip starts, we have another model which characterizes only that particular content type. That's how it works. Which means, if I can go back to here, to shift from, from the model you have on the left to the one you have just in the middle over there. From there, you have to go there, and you keep going in real time, analyze the experience of the end user.
Any other questions? So actually, I have one. First of all, I'm also very surprised that with 3 states, you are capable of capturing all the complexity of web workloads today. On top of this, I think from the network, you fail to take into account the impact of the platform. The fact that I have downloaded the packets on my mobile phone doesn't mean that my page actually renders. So I'm not entirely sure how you can bridge the gap between what my device is doing with the network traffic it just received. And I think this is very, very complicated, and it's very handset specific as well. Depending on the implementation that you're running, some pages, for instance, iPhones render pages very quickly. Android phones may render them much slower, so the user experience is going to be affected by this. And I'm not sure if the session actually reflects this. The second thing is that, at least in Barcelona, we have an entire team that works on human-computer interaction, and they form user studies in order to map quality of service with quality of experience. So how did you manage to did you actually get user participation? You did user studies to assess this, to validate those models?
Yes. So the first question, we just parameterized the model.
For different platforms?
Yes, we parameterize it. So like the key point in the experience, if I go here, this is important slide. There's no model, I can tell. There's no model that does not require training, yes. So that means, to answer your questions, probably is just one answer, is that First, we have parameters so that you can tune these parameters, like the length of a web page. It could be good if it is below 4 seconds, maybe 2 seconds. You can parameterize it. Our measurements, they are segmented, so you can bind the indicator to particular devices, to particular end user, to particular contract types. So all the information around that comes with our measurements. We talk about segmentation. I don't know whether that would resolve the problem. So what you would need to do if you have really a particular population of terminals or end users, we need to train once the model with your parameters. To train it, there's no way. You need to have subjective tests. Yes. Then the second question was?
How did you actually derive those functions of KPIs to reflect quality of experience? Did you do user studies on this?
We have several studies depending on the state. So, for example, if I go, yes, if we look at YouTube, for example, we have different states. When we are in the big state inside there, that the end user is starting joining the streaming video, we have one specific model that determines the QoE. And we call that model as a function that reports just as a number. When you have different transactions, like you pass from that state to the rebuffering state, or the end users closes a session, we have other indicators tied to that particular session data record. And we do it, we have our functions, and then at the end, we calibrate the function with subjective data. And we believe they are repeatable within the constraints of that particular populations.
Okay.
So that's how we do in high level.
Anything else? Okay, so we move. Thank you so much.